Titration is an experiment where the volume of one reagent, the titrant, or the standard, is measured, and it is reacted with a measured amount of another reagent. The other reagent is our unknown. And the whole point is to determine the unknown concentration. Neutralization reactions lend themselves particularly well to analysis by titration. If your titrant is an acid, then your unknown is the base. On the other hand, if your titrant is the base, then your unknown is the acid. The use of an indicator dye tells you whether you've hit the endpoint of your concentration. An indicator dye is what is known as a halochromatic compound. In other words, it changes color with changes in pH. Phenolphthalein is one such commonly used indicator dye. It's clear in acidic solution, and it's pink in basic solution. A burette is this device. It allows you to measure the amount of solution that you've added to the flask. So if we start out with just acidic solution in the flask, and we add phenolphthalein, the phenolphthalein turns clear. Then we begin adding base using the burette. As the base is added, you will see some pink color form and then quickly dissipate as it is neutralized. At the point where you have an equal amount of base added, or rather an equal amount of hydroxide ions added, well then you start to see the pink color persist. And that's how you know you've exceeded the endpoint of your titration. So here's an example of a typical kind of titration problem. 22.59 milliliters of 0.1096 molar hydrochloric acid is used to titrate 25.00 milliliters of NaOH. What is the molarity of the base? So the HCl is the titrant, and the NaOH is the unknown. You can approach this just like a stoichiometry problem. So, we can write a balanced chemical equation first of all. HCl solution plus NaOH solution produces NaCl aqueous plus H2O liquid. We're trying to find the molarity of the NaOH. That'll equal the moles of the NaOH over the liters of NaOH. Well, we know the volume of NaOH. We can convert that to liters pretty easily. We get the moles of NaOH from stoichiometry. Specifically, we'll take the milliliters of HCl, we'll convert it to liters, we'll convert that to moles of HCl. From moles of HCl, we convert to moles of NaOH. Et voila! So here's what this actually looks like. 22.59 milliliters, convert to liters, 10 to the negative 3 liters, is 1 milliliter. Milliliters cancel. We now use the molarity of the HCl, 0.1096 moles of HCl over 1 liter, right? That's the molarity that comes from here. And now we can cancel liters. So now we have moles of HCl. Now we need to convert to moles of NaOH, and we use the mole ratio from the balanced equation. The coefficient on HCl is 1, so we put 1 mole of HCl on the bottom, 1 mole of NaOH on top, because the coefficient of NaOH in the balanced equation is also 1. So now moles of HCl is cancelled. And we'll quickly plug this into our calculator. And we get 2.476 times 10 to the negative 3 moles of NaOH. We're almost there. We're going to plug that in to our molarity equation. Now we just need liters. We have 25 milliliters of NaOH. 10 to the negative third liters is 1 milliliter. That's 0.025 liters of NaOH. So that'll go here. So when I punch this all into my calculator, I get 0.09903 molar. Here's an exercise for you to try. Pause your video and work out the answer. When you've got it, unpause and check what you got against what I got. So here the nitric acid solution is the unknown. So I want to find the molarity of the acid. So the molarity of the acid is going to equal the moles of the acid over the liters of the acid. Moles I get by stoichiometry. And liters, well, I've got 10 milliliters of the acid, so that's 0.0100 liters. So let's do the stoichiometry. It's going to look like milliliters of base, convert to liters, convert to moles of base, convert to moles of acid. With the actual numbers, I have 3.6 milliliters of NaOH. Convert to liters. 10 to the negative third liters is 1 milliliter. Milliliters is cancelled. Now I use the molarity to get to moles. So 1 liter on the bottom and 0.20 moles of NaOH up top. Liters cancels. And now I just use the mole ratio to go from moles of NaOH to moles of HNO3. And the coefficient for HNO3 is 1. The coefficient for NaOH is 1. So moles of NaOH cancels. And the calculator says that I have 7.2 times 10 to the negative fourth moles of HNO3. So, the molarity of the HNO3, 7.2 times 10 to the negative fourth moles over 0.0100 liters. And I end up with 0.072 molar.